Okay, so we're just left with the last bit, but it's definitely not the least important. In fact, I think it's the most important bit of functions, and that's of composite functions, right? And in your A levels, in your AS, or yeah, AS, you will see a lot of questions on this if you open the marking scheme, and they continue to give these questions because I think maybe a lot of students get it wrong. And it's very important to not only understand just how to do it, but also the reason why we do it in such a way so that you can also dodge tricky questions, right? So composite functions, what you can probably tell by name, what does composite mean? Means something along the lines to combine, right? So, for example, if I have f of x, if I have some function f of x which is x squared, right? If I have some function which is 2x plus 1, right? So, what composite function would actually look like would be g f of x, right? So, let me draw a few number lines to try to explain to you what's really going on. Right. And for the time being, let us ignore the domains of these two functions. Let's just say they're all real values, right? We'll talk about domain a bit later. Right. So this is your line one, line two, line three. These are your inputs. So 0, 1, 2, 3, right? Can also, of course, be negative. And what gf of x basically means is that there's some input, you plug it into f, and whatever you get from it, you plug it into g. Whatever you get from that is your output, right? So your initial input was x, and whatever you get after g was your output. And for any, no matter how many letters there are, a b c d g f x, right? You always start from where you go to the left. That's just the convention we have chosen, and I'll show you using these number lines why that makes sense. So these are our inputs, let's say, and what's really happening to it is that first of all, it is going through the function f of x, right? So 0 goes to 0, right? We are squaring the numbers. 1 squared is 1, negative 1 squared is also 1. 2 is 2 squared is 4 somewhere there, and 3 squared is 4 somewhere there. 3 squared is 9 somewhere there. Right. Now that you have these values, right, what is happening to them is now you take these values and you plug it into g of x, right? So g of x is 2x plus 1. If you plug in 0, you get 1. If you plug in 1, you get 3. If you plug in 4, you get 4 times 2 is 8 plus 1, 9. If you plug in 9, you get 9 times 2 is 18 plus 1, you get 19, right? So when I say g f of x, this is what's happening. I'm taking x, I'm plugging it into f first, right? Whatever value I'm getting, then I'm inputting that into g of x, right? And I'm finally getting my end result. So what g f of x directly does is that instead of all these intermediate steps, it goes directly to this, right? So let me take an example. And one thing you might also notice here, you would agree with me that the output that f of x gives is actually the input that g of x takes in the function g f of x. Right. So let's concentrate on this number 2. So when I input 2 into f, I get 4. And then when I input 4 into g of x, I get 9, right? So first of all, if you've been given these two functions, they can of course ask you to find out gf of x. And the way you do it is that you plug in f into g, right? So the function f is x squared, so you plug in x squared, instead of x. Wherever in the function g of x, wherever you see x, you replace it with an x squared. So this becomes 2x squared plus 1. Right. So, oops. So gf of x is actually 2x squared plus 1. And just to quickly show you, gf of x is definitely not equal to fg of x, right? So fg of x would mean you plug into f 2x plus 1, right? Wherever you see x, so this will become 2x plus 1. This will be 4x squared plus 4x plus 1. And this is definitely not equal to this. So g of x is not equal to fg of x, right? Okay, so that's out of the way. Now 2x plus 1, right? So here I saw that when I concentrate on the value 2, it first goes to f, it gives me 4, then I take 4 into the input and it gives me 9, right? So if I directly input 2 into it, it should also give me 9. If I directly input 2 into gf of x, it should also give me 9, and it certainly does, right? Because this is how it acts, right? So this is what composite functions are basically. And the part where students maybe get confused is when you start including domain and range, right? You notice that over here I ignored the domain, and that was for a reason, right? So now let's bring domain and range into the story. Right. So let's take the same example. Let's say f of x is x squared, and let's say that its domain is, let's take x values greater than 1. Let's take g of x, which is 2x plus 1, and let's say its domain is x greater than equal to, let's say, 4. Right. And just to recap what the domains basically means, that if your domain is greater than if your domain is greater than equal to 1, this certain function will only take values that are greater than equal to 1. If you input into it anything less than 1, it will not give you anything. That's a sin. You can't do it. Right. So let's say I've given you this and I ask you, what is the domain of this function? Right. So let's refer back to our lines, right? Let me draw some of these. Right. So this is your input, right? The first line, second line, third line. And here you would probably have to listen a bit closely because there will be a lot of f of x's and g of x and domain and range. And hearing a lot of them in the same sentence might be a bit confusing at first. Right. So what gf of x means is that you take the input, you input into f, and then you input into g. Right. So first, let's concern ourselves with f. Right. So when I'm drawing the input line, I will only include values that are greater than 1. So if I take 0, it will not go through the function f of x, right? So let's take values that are greater than 1. Let's take 1, 2, 3, right? And these values, they go through f of x, right? F of x is basically x squared, so 1 goes to 1, 2 goes to 4, 3 goes to 9. All right. And now these values, they will go through g of x, right? So if it was 9, it will go to 19. If it was 4, it will go to 9 somewhere there. And if it is 1, it will go to, well, actually, you know, it will go nowhere. And the reason it will go nowhere is because this. Right, so when you look at the domain of g of x, the domain of g of x is actually x greater than equal to 1, and what it means is that it will only take values that are greater than equal to 1. 1 is certainly not greater that are greater than equal to 4. 1 is certainly not greater than or equal to 4, right? So it will only take values as long as they're somewhere over here, right? So if I concentrate on this value 1, right, it was okay for 1 to be inputted into f of x because that's under its domain. But when you input 1 into f of x, it gives you an output such that it is not within the domain of g of x. It gives you an output such that you cannot input it into g of x, right? So you know that g f of x gives takes you directly to that line, and we know we won't end up at the finish line for the value 1 or for any value less than 4. We know that our original domain cannot include 1, right? It has to be some value greater than 1, right? So 4 is the least value. 4 is the extreme point that g of x can take, right? And you get 4 when you plug 2 into f of x, right? And if you plug in any value greater than 2, you will get an output that is greater than 4. If you get an output that is greater than 4, then g of x will be able to work on it, and g of x will produce some output that will be uh, greater than equal to 9, right? So by this explanation right there, you can tell that the domain for this will be values greater than equal to 2, right? But most of this was all a part of me trying to explain the idea behind it, right? When you're in an examination, you won't sit down and start drawing lines, right? So just to give you something that is more mechanical, something, a group of steps that you can follow such that you end up at your answer, right? And you have practiced it, so it becomes your second nature.